Okay. Okay, so last time we said we can convert log into exponential and exponential back to log, because these two functions we define it as inverse of each other, right? So the main thing that will be very, very useful is this following form that I'm going to write. So when we have exponential function, we have this, right? We have input equal to base the output, right? So this is what we call the exponential form, right? Or exponential equation, you may say. This is exponential form. Now, this form, I'm going to put arrow in both sides, so that means one will always imply the another. So this can be converted to a log form. So log, the base is right here, and input is what you put inside right here, equal output. And this is exponential form. I'm sorry, log form, right? This is log equation or log form, let's say. Okay. So this will be the main thing that will help us to do lots of different things when we're working with exponential or log. So let me just give you an example of each. Like, okay, so if you have this form, then you can convert it into that form to do whatever you need to do. Okay, and then same thing, if you have this form, then you can convert it back to this form to do whatever you need to do. Okay, so okay, so let's start with an example. So here is, let's say we have an exponential form, so we have 2 equal to 5 to the x. So we're solving this, let's say, right, for x. And remember, I said this type of equations are not easy to solve by hand because of you can rewrite the 2 using the base 5. So you need to do that. So for instance, if this was 25, yes, that would be easy, right? So I could write 25 as 5 to the 2, and x will be 2, right? So to solve this is what we use. And I will just convert this into the log form, because now I have this form, input equal base to the output. So input is 2, base is 5, and output is x, right? So then I'll just write log, okay, and I take the base and put it right here. Okay, and this is input, and I put the input inside. This is 2, and x is the output, so x will be on the other side. So then x will equal to log base 5 input 2. So we have the x already. Okay, that's your answer for the solution of this equation. But sometimes we may write the solution in algebraic form like this. So this could be an answer. We put stuff right here. Or sometimes we have to find a numerical, answer corresponding to this. And that's a calculator related problem. So you're not going to do anything by hand. So you can just enter this as it is in your calculator and then find the approximated x value. X is usually not rational in this case, so you can just approximate it. But now some calculator, I don't know which one you're using, but some calculator you'll be able to enter the expression as it is. Just put the base and then put the input. And if you're using like, a simple one, a simple calculator, you might not be able to put the base like this, but then you can just do this. Let me write that as well. So x equal 2. So then you can do log 10 is default already in your calculator. You don't need to put a 10 as a base. So this will be 2, hit the log of 2 and the log of 5. Okay, and then just put like this in your calculator. So for instance, you can try it if you have one, even phone calculator will do this calculation. So I'm just going to use this. So let's say I do log 2 divided by log 5. And that's like 0.43 approximately. So I will just write here. Okay, so if they want you to find an approximated value, you will see, like in the homework, for instance, you will see there's a note there that says that approximated or rounded to the nearest 10 or rounded to the nearest 100 and so on. If you don't see that, then you can just put this algebraic form as an answer. So that's that. When you have exponential, if you start with an exponential equation or exponential form, you can convert it to a log to find a solution to that equation. And you can do this with any type of exponential form, whether you're doing by hand or you're not doing by hand, anything. Okay. So that's that. Okay, now let me give you this, and then we'll convert it into that solver. So any question here? Okay, now let me give you the reverse problem. The reverse problem will be this. So let's say we're solving this. Solve log base 3, and then here we have, let's say, 2x plus 1 equal let's say 4. So since I have a log form, so then I have this. So I always have three things, right? Three numbers, right? I have base, input, and output. So then I'm going to convert it like this: input equal to base and output. Let me write those things. Okay, so this is the base. The one we have inside this guy is input. And then this right here is the output. Okay, so then I'm writing this. I'm writing input equal to base 2 output. Okay, which input is 2x plus 1. So I'm putting here 2x plus 1 equal to base is 3, and the output is 4. And then I solve this for x. And then I can just do this. So 2x plus 1 equal to 2 to the 4th power is, so you'll multiply 3, you'll multiply 4 3s, which is 81. Okay. 81. And then I'll subtract 1 from both sides. So this will be 2x equals 81 minus 1. 2x equals 80. And then I'll divide both sides by 2, right? So if you divide both sides by 2, then x will equal to 80 divided by 2, which is 40. So x equals 40. Does this make sense? Okay, perfect. So we'll always come back to that form, and I will tell you, remind you. Okay, now let's. Okay, now the part that is remained from that previous homework is computing two things: computing domain of log functions and computing the inverse of a function. So remember, like an inverse, I write down the steps for other type of functions. So the same steps are going to be, we're going to be using the same steps over here as well. But let me start with the domain first. So when we are finding, so when you have a log function, the function will be in this form, right? It will be log, and then you will have some base here, let's say a, and then you will have something inside, right? There might be a number as a coefficient, and there might be something added or subtracted, but that's not gonna be involved for the domain. What's gonna be involved in domain is the input, basically. So here I have input, and this input can be an expression, it can be anything. So let me just say input right here. Okay, the input is some expression. Some expression. Okay, so to find a domain, we'll just do this. So let me write it in steps. So step 1. Okay, first input must be bigger than 0, strictly bigger than 0. Okay, and that becomes an inequality, right? So then you have to now solve an inequality. Okay, so this is an inequality. So in step 2, I will solve this inequality. So solve this inequality for the variable, right? Then you have the domain. So I'll put a note here. Since I already said this has to be strictly bigger than 0, so we don't have this. So log any base a, if input is 0, then this is not going to equal to a number. So this does not exist. Input cannot be 0. This does not exist. Okay, that's one thing. And then 2, the input cannot be negative. So I cannot put here a negative number. So whenever input is a negative number, then we say this does not exist. If this is a negative number, this does not exist. You have to watch for this two situation. Okay, but as long as I just do these 2 steps, I will always find the correct domain. But I just want to kind of tell you that. So we cannot compute log of 0. And then we cannot compute log of a negative number. So such things does not exist. Okay, so let me give you guys an example. Okay, so find the domain of f of x equals, let's say 5 times log base 3 for x minus 3. So that 5 is not going to affect anything. So all I need to do is just look at the input. Like I said, input has to be bigger than 0, and that's all matters. Okay, so step 1. So step 1, input must be bigger than 0. And what is the input in this case? Input is what you see inside right here. This is the input. It's an expression, right? So input must be bigger than 0, which is 4x minus 3 must be strictly bigger than 0. Okay, and then we solve this for the variable because this is an inequality now. So I will just, so remember I showed you different types of inequality. We had linear inequality, we had quadratic inequality, we had rational inequality, right? So each one has steps, but this one is kind of basic now, right? Linears are always basic, so we can easily solve it. So step 2, solve this. So solve this for x, which I will have to just add 3 and divide by 4, right? That's all. So if you add 3, this will be 4x bigger than 3. If you divide it by 4, this will be x bigger than 3 over 4. So for the inequality, for such linear inequality, you have to be careful. So when you're dividing by a positive number, nothing changes. But when you divide it by a negative number, you will have to switch this symbol to the opposites. And when you multiply by negative, you will also have to switch. So just be careful there. I mean, everything is positive here, so that's why nothing changes. Okay, now we have the domain, right? Because this is bigger than 3/4, and bigger than 3/4 means that starting from 3 over 4, you will go to positive infinity, right? So therefore the domain of this problem will be 3 over 4 to positive infinity if you write it as an interval, right? Okay, any questions? Now let me give you another example.
To find the domain of an exponential function, do we just convert it to a logarithmic function then?
Well, for exponential function, you don't need to do that because domain of the exponential function is always all real numbers. Yeah. But if you want to compute the range of the exponential function, then the range of exponential function will be the domain of logarithmic function. So for instance, if I had an exponential, so I'll show you the inverse, and I'll show you how we were switching the domain and range for inverse and the original one. So I'll kind of remind you that when we do the next example. Okay. So since I'm recording this for some people who were missing today, I will also share this link with you so that you can also watch it later if you kind of forget things. Okay. So are we good here? Okay, now let me give you guys another example. Find the inverse. Find the domain. This one sometimes does this. Let me see if I can fix this. Find the domain of this function. Log, let's say base 7. And then I have this 2x minus 1 divided by x plus 3. So the input is now not linear, right? Input is a rational, right? It's a rational function input. So when I say input bigger than 0, then this will turn into a rational inequality. And that was like the section before this topic. And I'll remind you. So step 1, input has to be bigger than 0, right? So step 1. So input must be bigger than 0. And the input is this whole thing, right? Input is what you guys see over here. So this whole thing is the input. And then when I say input bigger than 0, then I'm writing this 2x minus 1 over x plus 3 strictly bigger than 0. And this is a rational inequality. Remember, the rational inequality, what we do, we factorize top and bottom, right? Since one hand side is 0, so then we don't need to rewrite it, right? All we have to do is make sure the top is factorized completely, the bottom is factorized completely, and then we put those numbers on the real line and test it, right? So everything is factorized now, so I don't need to do that step. All I need to do is set the top to 0, so 2x minus 1 equal to 0, and this will give you x equals 1/2, and set the bottom to 0, x plus 3 equals 0, and this will give you x equals -3. So these two numbers are the one that I put it on the real line and test it. Let's do that over here. And do that over here. So I put this line here. And then -3 is right here. And 1/2 is right here. This is -infinity and +infinity. So since the inequality is strict, right, and I will not include the number that comes from the top and the number comes from the bottom. Number comes from the bottom is never included anyway. But since this is strict, I do not include any of them. So then I will use a parentheses for each number. Okay. And now I'm testing it. So I'm just going to pick something bigger than a half, which I can just pick 1. And then I will plug it right here, right? Plug right here to see if it satisfies this. See, if you put 1 here, it's going to be 2 times 1 minus 1. That's 1, right? Let me do the calculation. So it's 2 times 1 minus 1 over 1 plus 3. Is that bigger than 0? Yes, because this will be 1/4, right? So 1/4 and 1/4 is bigger than 0. So then therefore any number here will satisfy it. So the interval that I will get from this piece, this interval right here is 1/2 to infinity. So any number in that interval will be the solution to this inequality, right? Now let's test the next one. And the next one is going to be this interval, right? From -3 to 1/2. So I'll pick a number again. Let me pick 0, right? 0 is there. And then I'll just plug it in. So it's 2 times 0 minus 1 over 0 plus 3. And this should be bigger than 0 if I want to take this, which is not, because this is -1 over 3, and that's not bigger than 0. So this one did not satisfy, so I don't take this. And next, I check this one now. This one, I can just pick x equal -4, and then plug it in, so it's 2 times -4 minus 1 over -4 plus 3, which is -9 divided by -1, and that's +9, and that is bigger than 0. So this one did satisfy, so therefore this interval is -infinity to -3. So I have this interval and that interval, so now I need to put it together, so to finalize it, so the domain will then be -infinity to -3 union 1/2 to +infinity. Good. Okay, perfect. That's how we compute the domain of the log function. Now let me show you how to do the inverse. So finding the inverse of log functions. So we had those steps. So I gave you those steps before, so I will not repeat those again, but let me just kind of show you guys this on an example. So let's take this function. Okay, so let f of x be the log base 3, and then here let's just start with something simple. Let's say x minus 1 first, and then we're going to compute the inverse of this function. So to compute the inverse of just like a general function, we have this general steps, right? Step 1 was replacing each x with y and replacing y with each x, right? That was the first step. And f of x is y, right? This guy is y. So I'm replacing, so step 1, replace each x with y and y with x. So this is going to be x equal to log base 3 and then y minus 1. And I have to solve this in step 2. I have to solve this for y, right? So to solve this for y, solve for y. So to solve for y, remember, we had this main thing that I gave you in the beginning, right? In page, okay, let me go to page 1 to remind you. This main thing right here, right? So what we said, if I have a log form, and if I'm solving this for something, right, for some variable, then I will have to convert this to exponential form. And vice versa. If I have an exponential form, if I'm solving for a variable, then I have to convert it to a log, right? Okay. So now since I have a log, then I have 3 things. I have input, which is inside, I have a base right here, and then I have the output on the other side of inequality, either side of equality, right? Okay. Let me write those numbers again. So what I have here is called the input. And what I have here is called the base. And this right here is the output. Okay. Now let's write input equal base to output. So input is y minus 1, and the base is 3, and the output is x. So 3 to the x. And since I'm solving this for y, I just have to get rid of -1 by adding +1 to both sides, right? So then y will equal to 3 to the x plus 1. And once y is by itself isolated, then you have the inverse function. So then you're done. So then I will just write here f inverse of x equal 3 to the x plus 1. And that's my inverse function. Now, let me also tell you the domain of this because we want to make that connection, right? Domain and range connection. Okay, and let me do that over here, right here. So what's domain of this function? Domain of the original one. I know the domain of this one, right? So what is it? What is domain of that one? All real numbers, perfect. Because this is exponential, right? So the domain of this should be all real. So let me just write it here. Domain of the inverse is all real, so that's this. So the domain of the inverse is going to be the range of the original function, right? So let me. Okay, so the range of this function is going to be. I'm looking at this function, right? The range of this function is going to be domain of that function. Now let's look at domain of that function because domain of the log function is going to be the range of the inverse function. So what's the domain of that function? The log function. So what's the domain of log function? So what was the rule? The rule is input bigger than 0, right? So input should be bigger than 0. And what's the input here? What is the input of this function? X minus 1. So x minus 1 must be bigger than 0. So I'm going to write that. X minus 1 must be bigger than 0, which if you solve this, then this is going to be x bigger than 1, right? And that is 1 to infinity. X bigger than 1 is 1 to infinity. So that's the domain of log function, and the domain of log function is going to be the range of inverse function. So now I will just write here, I will put here 1 to infinity. So that answered your question. Give you guys another example for finding the inverse. This is okay. Any question? Okay. So this time I put a coefficient there and I also put a number there. So when we do that, so we really just have to first isolate the log, because before you convert it, right? Before you convert it, let me just go back to this form again. See, before you convert it, it has to be like this. It has to be exactly like that, which means we don't have any coefficient and we don't have any number that is added or subtracted from log, right? It has to be simple like this, which means the log must be isolated. So now if I go back to this form, I'm gonna have to clean a little bit, right? So I'm gonna have to first get rid of 6 and then get rid of 3. Then I will convert it, right? But you can go ahead and replace x with y and y with x if you want to. So let's do that first. So step 1. So this is a y and this will become x equal 3 times log base 7. And I will just change x to y. So this will be 4y minus 3 plus 6. Okay. Now let me do that, right? The process is, okay, first isolate the log form before you convert it. So first subtract 6, that's x minus 6 equal to 3 times log 7 4y minus 3. And then now I need to get rid of 3, so I'm just going to divide both sides by 3. This cancels out. Then I have x minus 6 divided by 3 equal log base 7 4y minus 3. Now it's isolated. Now we're ready to convert it to an exponential form, which is this again. So I have these 3 things, 3 numbers, and I'm going to write it like this. I'm going to say input equal base to the output. Okay, let's do that right now. Okay, so this is the output. This is the input, right? And this is the base. Okay, so I'm going to say input equal to, so 4y minus 3 equal to base to the output, and output is this whole thing. So it's going to be x minus 6 divided by 3. And then I'll solve this for y, right? That's step 2. So to solve this for y, I'm going to have to add 3 to both sides first. So 4y equal 7x minus 6 over 3 plus 3. Then I will divide both sides by 4. So when you divide both sides by 4, you will get y equal to, okay. So this whole thing is going to be divided by 4. This. So then you have the inverse function. So then at inverse of x will equal to 7 to the x minus 6 over 3 plus 3 divided by 4. That is the inverse function. So, question so far? Now, I want to just tell you, like with an example, I want to tell you the connection between the graphs. I mean, we're not going to do much with the graph from now on, but I will just kind of just show you one with a little example. So remember, if I take this guy, right? Let me just take, so here's another example. So let's take this function, f of x equal to log base 2 x minus 3, let's say. So here we have a couple of things, right? So we know the domain of this function. We know how to compute it now, right? And we can compute x-intercept and y-intercept because we know how to solve it now. And then we can compute the vertical asymptote, right? So a couple of things. So first let's do this. First, let's find the domain of this function. Okay, we know that the domain is input bigger than 0. So input is x minus 3. This is bigger than 0. Will give us x bigger than 3, right? Which is 3 to infinity. So we know that the entire graph is going to be on the right-hand side of 3, right? And then 2, then we have the vertical asymptote for this one. Vertical asymptote, which the vertical asymptote has to be input equal to 0. And input is x minus 3, so x minus 3 equals 0. And this will be x equal 3. So x equal 3 is the vertical asymptote. And I want to compute I want to compute, let's say, the y-intercept. Let's start with the y-intercept first. So for y-intercept, how do we compute y-intercept? We make x 0, right? Just for any function. Okay, make x 0, so let x to be 0. If x is 0, so I'm going to take 0 and plug it into the x in the function. So then you have this. You have y equal to log base 2, 0 minus 3, which is log base 2 minus 3. Okay, now what do I say there? Can I compute that number using my calculator? No. Why? Because input is negative. Remember in the beginning, I said, I think I put a note here. Was it the second page? Yes. You see, I said input cannot be 0 and input cannot be negative number. In these two cases, we don't have any number corresponding to that. So therefore, this does not exist. So then we're not going to have y-intercept. So we don't have y-intercept. So now. Okay, now next I'll look at the x-intercept. So to find the x-intercept, I'm going to make y 0, right? So y will equal to 0. If y is 0, then I have this. So I have 0 equal to log 2x minus 3. Now, what kind of equation is this? Log equation, right? To solve a log equation, what do? Convert it to an exponential form, right? So I have a log equation, which is a log form. To solve a log form, I convert it to exponential form and vice versa, right? So how do I convert this to an exponential form? How do I convert this to an exponential form? Is this, right? You see, I'm always going back to this, right? I'm always going back to this. If I have a log form, which means I have this guy, right? If I have a log form, I have this guy, this right here. And then I take this and convert it to this form, right? Make sense? So when I have a log form, I have this. And I have 3 numbers, base, input, output. And I take those numbers and put it right here. So let's do that now. Okay, so the input is going to be x minus 3. So it's going to be input equal to, so x minus 3 equal to base to the output, and output is 0. So base to the output, 2 to the 0. And we know 2 to the 0 is 1. So then we'll have x minus 3 equal 1. Then add 3 to both sides, so x equals 4. So x-intercept is 4, so means that the graph is going to pass through the 4 on the x-axis, right? And then we have no y-intercept, so our graph is not going to pass through the y-axis at all, right? And then we have the graph on the right-hand side of 3 because our vertical asymptote is 3 and the domain is from 3 to infinity. Okay. All right, so putting all this together, then I will just come up with this. So we're going to have 1, 2, 3, 4. This is an x-intercept, and then I have the horizontal asymptote, x equals 3. And remember, the domain is from 3 to infinity, so the graph is going to be entirely over here, right? And you remember the graph of log function, right? Because remember in the beginning, I kind of give you the parent function. It was like this. It was like that, right? So you had exponential like this, and then the inverse was like that, right? So basically, I'm just going to take this and just pass through this. I'm just going to pass through this point, and it's going to be like that. So the graph will always be, so it will always be on the, so like you have, if you compute the x-intercept and the vertical asymptote, then it will always be on the other side of the asymptote. It could be on the left too, but in this case, it's because domain is bigger than 3, so it's on the right side of the asymptote, but it could also be on the left side too, depending on the domain. Makes sense? And then the function, okay, let's see, where was that? Was that here? No, it's here. Okay. So, oh, we didn't compute, so this, we didn't compute the exponential form corresponding to this. So if you compute the exponential form corresponding to this, then you will see that the inverse of this function is exponential, and it's exponential growth actually, right? The base is 3, so then it will be like somewhere right here, somewhere right here. Okay, so what is the exponential corresponding to this? Let me also write that. So the exponential corresponding to this will be, so first I will write it like this. I will say x equal to log 2 y minus 3. Then it will be 2 to the x equal y minus 3. Then add 3 to both sides. So 3 to the x plus 3. And that's the inverse function. So I can put the inverse function on the same graph like this. So the asymptote is going to be 3. So 1, 2, 3. So then it will be like that. Okay, so these two guys are, so this is 4, 0. Remember, this point is 4, 0. And then this right here is going to be 0, 4. Remember, because you're switching, right? You're switching the point, so this will be the y-intercept of the exponential function. Does it make sense? Question? And we'll stop.